Alright, transformations number 1. So page 74, number 60. Page 74, number 60. I don't know why I have page 74, number 60. It should be 74, number 50. On number 50, we are given a right angle, which means that these have to be complementary angles, which means both of them have to add up to 90. So I would be given 5x plus x minus 60, or 6, has to equal 90. Therefore, if I solve this, I get 16. Number 51. I have two straight lines. These have to be vertical angles because they're across from each other, which means that they must be equal. So, I have 14x minus 13 has to equal 12x plus 7. If I get rid of my 12x, I get 2x. Add 13, 2x equals 20. Divide by 2, and I get x equals 10. This time I have two variables. I know that this angle and this angle are supplementary. And then I know that this angle and this angle are vertical, or even this angle and this angle are supplementary. But the first thing I need to do is find x. Once I find x, I know one of these angles, and then I know what y is. So I'm going to go ahead and I'm going to take 5x plus 6 and add that to 17x minus 2, and this has to equal to 180. When I solve for x, I get 8. If I know that x is 8, the one that I think is easier is I'm going to go ahead and find this angle, because if I find this angle, then y is vertical, which means it has to be congruent as well. So 5 times 8 plus 6. 5 times 8 is 40 plus 6. So my y has to be 46. Page 79, number 5. Name the intersection of lines AC. So intersections of lines would be a point. So here's A, here's C. So they intersect at point P. Give another name for line B. Line B is right here, and a different name for a line would be 2 points on the line. So ST, and then I need to draw the arrow on top, the line, and that would be another name. Number 7, name a point that is not contained in any of the three lines. Well, W is not on any of the three lines. And then give another name for plane WPX. My plane is a capital italicized R. So I'm done with this. Page 79, number 11. It says find the value of the variable. Find the value of the variable and xp if x is between pq. So x is between, so right in the middle, here's x, here's p, here's q. So xq is 13, so xq is 13. xp is 5x minus 3, so xp is 5x minus 3. And then PQ is 40. So when I look at this, I know that this plus this has to equal the entire thing. 5x minus 3 plus 13 has to equal 40. so that's a 5. So 5x. If I were to solve for x, I would get 6. Once I get 6, then I need to find xp. xp is 5x minus 3, so that would be 5 times 6 minus 3. 30 minus 3 would be 27. So what equals 27? Line segment px. Page 80, number 16. Find the distance between each pair of points. Find the distance between each pair of points. So A is negative 3, 1. B is 7, 13. So I need to find the distance, which means I'm going to use the distance formula. x2 minus x1 squared plus y2 minus y1 squared. So if this is x1, y1, x2, y2. So x2 would be 7 minus y1 would be 1 squared. My y2 would be 13. Whoa, sorry. 7 minus negative 3 would be plus 3. Sorry about that. 13 minus 1 squared. So this would give me 10 squared plus 12 squared. This would give me 100 plus 144. So this would give me 244, the square root. If I were to go ahead and simplify this, which I want you to always, 244 divided by 4 would give me 61. I can break down 4, which is 2 and 2. 61 divided by 3, nope. So I can't break down 61, but I broke down, and I have a pair of 2's. The pair of 2's goes on the outside, so 2 square root 61 is what I would be looking for. Number 19. Find the coordinates of the midpoint of a line segment given the endpoint. So number 19. My endpoints are 32, negative 1, 0, negative 12. This is C, this is D, and it says to find the midpoint. So x1, y1, x2, y2. My midpoint would be x2 plus x1 divided by 2 is the midpoint of my x. And then y2 plus y1 over 2 is my midpoint of y. So x2 is 0 plus 32 divided by 2. That would give me 32 divided by 2 is 16. So my x value is 16. y2 is negative 12 plus my y1 is negative 1 divided by 2. That would give me negative 13 over 2, which is the same as negative 6.5. So my midpoint would be 16, negative 6.5. Number 23. Number 23, it says name the vertex of angle 7. Here's angle 7. My vertex is a point. That would be point G. That's what they have. Write another name for angle 4. Here's angle 4. Angle 4 would be C, D, G. So angle C, D, G. You could also have angle GDC, or you could have JDC or CDJ. All of those are the same. Name the sides of angle 2. My rays would be CA and CG or CH. Those are the same. So number 27, or sorry, number 25, yep, CA, CH. And then do we have 26? Yep, 26. Name a pair of opposite rays. Opposite rays. Man, there are a bunch. I could do, so opposite rays, so CB would be a ray. So the opposite of CB would be CG or CH. Okay? And we write rays like this. So they have CA, CD, but there are a ton of answers. Another one would be, oh, so there's not as many as I thought. So we have to use this line or this line. CA, CD, or CB, CG, or CB, and CH. And we are done.